build our calibration relationship between electrical conductivity and total dissolved solids, we're going to use a linear regression. But let's make a plot of our data to make sure that a linear regression makes sense. I've left a spot here on this spreadsheet or on this template for putting a graph underneath where it says create a scatter plot of TDS versus EC. So I need to go to the insert ribbon on Excel, and here's a group of charts that I can insert. And in this case, I want to put in a new scatter plot. And this is a scatter plot right here. And we're just going to use data points. We're not going to bother with lines or anything like that. So I'm going to move this scatter plot so it's in a nice spot on this table. And then I want to right click and select data for this scatter plot. In this case, I want to be able to have a model that lets me get from electrical conductivity to total dissolved solids. So I'm going to edit this series. And the x values, I want the x values to be electrical conductivity because I want to go from electrical conductivity or specific conductance to total dissolved solids. So I'm going to put specific conductance on the x-axis. And on the y-axis, I'm going to put total dissolved solids. Now I can add that plot, and we can see that we have these data that are approaching a linear relationship where with increasing electrical conductivity, we have increasing total dissolved solids. Now I want to make this graph, clean this graph up a little bit so I have good labels of everything. First of all, I'm going to call this TDS versus EC calibration. Also, for this graph, I'm going to click Chart Design ribbon up here when I have the graph selected, and I'm going to add chart elements. First of all, I want to add axis titles. So I'm going to add a primary horizontal title, and that title is going to be, I'll keep it the same as what's on the labels up here. I could also call that electrical conductivity. And I also, you should really never have a graph without units on the axis label. So this is going to be microsiemens per centimeter. And I need this to be a superscript. So on a PC, I can hit Control-Shift equals in order to make that a superscript. Also, I need to change the font of this M to be a mu. And to do that, I can go to Home. I can change the font. And I want to change the font to symbol. So that should turn, I highlighted the M before I did that. That should turn the M into the Greek letter mu for microsiemens per centimeter. Then I want to go ahead and collect my graph again, go back to Chart Design ribbon, add another chart element, and I'm going to add a primary vertical axis. And this is going to be total dissolved solids to be consistent with the headings on my table. And this is going to be in units of milligrams per liter. And again, I can highlight the -1, Control-Shift equals or plus sign, and that will make that a superscript. I can also highlight that, go back to the home menu, go under font, and I can make it superscript here as well. So I've got nice labels on my axes now where I've got specific conductance on my x-axis and total dissolved solids on my y-axis. And finally, I can actually put a line on this in Excel. So if I click on the data and I right click, it should give me an option to add a trend line to the data. So if I add a trend line, the default is a linear trend line, and a linear trend line is what I want to do because this looks like approximately a linear relationship. Also, in this case, there is a reason to expect that this line should go through 0, 0. Because if you don't have any dissolved solids in water, it actually does not conduct very well at all. It's a very poor conductor without any ions dissolved in the water. So I want to set my intercept to 0. I want to force my intercept through 0. And also, I want to display the equation of my model on the chart, which in this case, if I don't have an intercept, is just going to be a slope term. So I have a slope of this line of about 0.6372. So that gives me a way to visualize the data. And now I need to calculate that slope in a cell in such a way that I can use that cell for later calculations. So I don't just want to copy and paste this in there. I want this spreadsheet to calculate that for me. So the function I'm going to use to calculate that slope, I can't use slope because I'm assuming a 0 intercept. And in order to assume a 0 intercept, I need to use a different tool for doing a linear regression. Now I'm going to do this linear regression out here first to show you something. And I'm going to use the function called lineest. And lineest is similar to the slope function in that you have to tell it what the known y's are. Again, I want to predict total dissolved solids from specific conductance. So I want my y's to be total dissolved solids. And then I want my x values to be specific conductance, just like I have it set up on the visualization here. And then finally, this next argument is a constant b is set equal to 0, and the m values are adjusted to fit y max. So if I put a false in here, that means the b parameter, or my intercept parameter, is set equal to 0. So I do want a false here because that is how I force the regression to go through 0, 0. Now there's also one more argument that I could set called stats. But I'm not going to set that because this is what I need it to do, and I don't need any additional stats. I just need the slope. So if I go ahead and enter here, you'll see I actually get two different numbers from putting in that function. The first number is the slope, and the second number is the intercept. And remember, I forced the intercept to be 0. Now, when I put this function in here, I don't want that 0 to show up. I just want this 0.63724. The reason I'm getting two numbers here is because this lineest function returns an array of two values rather than just a single value. But if I only want the first of those two values, I can just put an at in front of this line st. And that at symbol will force it to just give me the first value, which is the slope that I want. So this is the function that I want. I want to have that at symbol in there to specify that I only need the first value that's returned by line st. And then I'm going to put this function into this cell. Oops. There we go, into this cell. And see, it's going to have that same number, 0.6372, and that also matches this number here. So now I can get rid of that. So now I have the slope of a linear regression line that's forced through 0 and through these data. And I have it in a cell so that if I need this number, which I will need later to convert conductivities to total dissolved solids, I can use this as a number in calculations in the cell. So now I'm all set with my statistics, and I can move on in the spreadsheet to convert electrical conductivities that were monitored at this particular gauge into total dissolved solids.